In this week's space news, we cover Outpost plans to put shipping containers in space. Next, we cover a Canadian startup that's building orbital gas stations. In other news, HyPrSpace, a French startup, is developing a hybrid rocket engine. And finally, Astrobotic makes progress with their lunar lander. Let's get started. Outpost plans to put shipping containers in space. There are many commercial and government organizations trying to launch payloads to space, but very few able to get significant payloads back. Cargo Dragon can return 3,000 kilos, or 6,600 pounds to Earth. Other crewed vehicles return only small amounts of cargo in addition to crew, such as Soyuz, Crew Dragon, and in the future Starliner. In-space manufacturing's entire business plan depends on making items in space and selling them on Earth, so getting payloads back safely is a crucial step. Outpost, an LA-based company, plans to return a spacecraft the size and shape of a shipping container back to Earth. So, how does the Outpost cargo return system work? Well, they combine a few technologies together that perform the magic. They consist of a satellite bus that carries a propulsion system, a heat shield to protect the cargo and slow down the cargo during re-entry. The container system provides two size options. The smaller container can manage payloads of up to 100 kilos or 220 pounds. And the larger option, equivalent to a standard 20-foot shipping container, can transport payloads of up to 10 tons. And finally, a robotic paraglider that guides the payload back to a precise landing. This is an intriguing space startup which we will cover in greater detail in a future video. Their small container is due to fly on a Falcon 9 rideshare mission in 2026, and their larger container flying on a dedicated mission in 2027. Okay, let's move on to our second news story about a company building service stations in space. Spaceium is a Canadian startup that's focused on in-orbit refueling and servicing. It was started by two students who built a rocket that flew to 30,000 feet when they were students at the University of Ottawa. They are moving fast and have a mid-2025 goal of launching their first in-orbit cryogenic refueling mission in partnership with Space Machines Company. A big problem with space missions, especially interplanetary, is there are no fueling stations in space. You need to send all the fuel for your entire mission from Earth. This severely impacts the type of missions you can do and the time it takes to move around the solar system. Imagine having fuel stations along the way. First launch to low Earth orbit, then refuel. Now traveling around the solar system is a lot easier. So that's the problem. What are Spaceium's plans to solve this problem? They are developing a state-of-the-art cryogenic fuel storage system for space, which can hold multiple metric tons of cryogenic fuel without experiencing any boil-off. The fuel storage system, or depot for short, will have a robotic arm attached to help with docking, refueling and repairing spacecraft. We have our robotic arm that we can use to transfer cryogenic fuel, non-cryogenic fuel, as well as provide repairs. So we have basically built a very modular core technology that we can adopt in the future. They have already received bookings for later in this decade. Their eventual plan is to position refueling depots in geostationary orbit and cislunar orbits. Next up, a hybrid rocket engine test from a startup in France. HyPrSpace tests hybrid rocket engine. A French space startup has just performed their first engine test. They have just completed their first bench test of a hybrid rocket engine. They are developing an innovative, patented propulsion system. This test successfully proves their rocket design works in practice. The test proves the reliability, performance and efficiency of their rocket design. They also learned how to operate a rocket engine with cryogenic fuels, which is a crucial step for future launches. This strategic project demonstrates HyPrSpace's ability to provide an innovative, competitive and responsive access to space solution, a representative from HyPrSpace stated. The company is positioning itself as a significant player in the new space sector and launch vehicle market. Next steps for the company include developing a liquid oxygen tank, adding thrust vector control system, and conducting tests that simulate real space flight conditions. They plan on a suborbital flight sometime in 2026. And finally, Astrobotic makes progress with their lunar lander. Astrobotic's Volt rover passes key lunar surface tests. Astrobotic wants to build a power grid system on the Moon. It has started a summer-long test campaign for its Volt rover. VOLT stands for VSAT Optimized for Lunar Traverse, VOLT. The VSAT acronym refers to Vertical Solar Array Tower that is used to generate energy. As the rover moves over the moon's surface, it has a 60-foot vertical solar array positioned so it always points at the sun to generate the most energy possible. The rover is designed to provide power to lunar surface assets such as habitats, other rovers and scientific instruments. Why is it difficult to have a rover where solar panels generate consistent energy? Well, the moon isn't flat, especially in the southern pole area where NASA intends to land. Crater rims can be steep, but they also contain lunar ice, so that's exactly where scientists want to go. Astrobotic is testing their rover for stability and sun tracking ability on a simulated lunar slope. Although the rover is designed for 15-degree inclines, it exceeded expectations and maintained stability on a 20-degree slope without any slippage. Robert Rowley, Astrobotic's principal investigator for VOLT, said, "To supply continuous power at the poles of the moons, we need to take advantage of existing peaks of persistent light, locations with near constant sunlight throughout the year. Since most of these locations are at crater rims with high slope angles, we designed VOLT to deploy on extreme slopes. These tests proves that our system can operate successfully, with plenty of margin for more extreme locations." Astrobotic's team developed a system to keep the solar panels pointing towards the sun to capture the maximum amount of sunlight possible. This is difficult considering the rover is moving up and down slopes and the sun is very low in the sky when operating at the lunar south pole. The VOLT rovers will be tethered to each other, which will create a lunar power grid. This system powers lunar assets during the lunar day and can survive by using generated solar power to heat critical rover systems throughout the lunar night, which lasts for 2 weeks. John Landrenau, Senior Project Manager at Astrobotic, said, "It's imperative that we solve the power generation challenge on the moon for sustainable long-term operations. VOLT's ability to precisely drive and operate in the most desirable areas for solar capture and distribution sets this technology apart. VOLT's ability to precisely drive and operate in the most desirable areas for solar capture and distribution sets this technology apart. With strategic partnerships and novel tech developed in-house by our team, VOLT and the Lunar Grid system are making great progress to bringing reliable power to lunar surface systems like landers, rovers, habitats, and science suites." Astrobotic aims to deploy and demonstrate Lunar Grid elements on the moon's surface by mid-2026, with the first operational Lunar Grid expected by 2028 at the lunar south pole. We can't wait to see this system working on the moon. We'll be sure to keep you covered on news from Astrobotic and other lunar space startups. Okay, that's it for this week's space news. Be sure to subscribe to get the latest news on commercial space startups around the globe. From rocket launchers to space stations, orbital tugs, lunar landers and more. If it's a commercial space startup, we cover it. See you soon.